Hello, everyone. In this week, we will continue our playlist about the applied medical statistics for practicing physicians. And I will say again, this is not a comprehensive epidemiological presentation. It's just brief refresher for practicing physicians, junior medical practitioners, medical students, and board exam takers to highlight the importance of some epidemiological measures and to provide examples about how to apply it and calculate them. So let's start our presentation for this week, and we will continue in the risk measures. So last time we discussed the relative risk, and in this presentation, we will talk about the absolute risk reduction and the relative risk reduction. So the absolute risk reduction is the difference in risk due to the intervention as compared to a control, also known as risk difference. So we have keywords here. The first keyword is difference. And when we say difference, that means we're going to do subtraction. Okay, the second keyword is risk. That means we will calculate risk. And we have spoken about this before, how to calculate the risk. And it's basically the number of patients or individuals who have the condition divided by the total number of that group that's exposed or the intervention group. So that's the risk. So the third keyword is comparing the intervention and control groups. That means we have to calculate two risks separately and subtract these risks from each other. So the risk in control minus the risk of intervention. And this is important. So we start first by the risk in the control. Don't imagine that we start with the intervention group. And why? What is the idea behind this? So the notion of starting with the control group is based on the assumption that since we are doing an intervention, we assume that there is some change will be done by this intervention to the better, right? So that's why we are introducing a new medication, for example, because we think that this medication will improve the outcomes better than the current situation with the control group or the placebo group, right? So in math, we usually do subtraction from the bigger number, which we assume here in this situation, the non-intervention group or the control group or the placebo group. By the way, all these names are synonyms. They all refer to the group that doesn't have the intervention of interest in our study. So we start with that group, we calculate the risk and subtract the risk in the intervention group. And I have a color code here to help you guys follow what I'm saying. So the control group or non-intervention group is highlighted in blue, and the intervention group is highlighted in green. So the equation would be the absolute risk reduction equals C over C plus D minus A over A plus B. That means we calculate the risk in the control group, we subtract it from the intervention group. Let's do an example as usual to make things in practice. This example says that an interventional study was conducted to evaluate the response of patients who have influenza in one hospital to Tamiflu. 40 patients out of the 60 patients who received Tamiflu recovered completely without complications. On the other hand, only 10 out of the 40 patients in the control group who received a placebo have recovered. What is the absolute risk reduction? So immediately we need a 2 by 2 table, but we need to fill in the numbers. I want to highlight one important information that I have said before, but I will reiterate and repeat it again here, that when you label your 2 by 2 table, try to put the outcomes in the columns. All the time, try to put the outcome in the columns and the intervention or the exposure in the rows. That means when we talk about column, we talk vertical. The vertical cells, we have to label them by the outcomes. And the rows, which is the horizontal cells, we label them with our intervention or our exposure, depending on the type of the study. So that will save us a lot, and that will secure our calculation in the future. So let's see in this example, what is the outcome and what is the exposure? We know that the exposure is a Tamiflu or the intervention, that we are introducing Tamiflu to patients who already have influenza or flu, and we have another group that's a control group or the placebo group that they receive a placebo. That means a medication. It's not Tamiflu. It's not any medication that have active ingredients. So this is the intervention and non-interventions. We fill that into the rows, as I said. The outcome is not influenza, non-influenza. The outcome is about recovery because the example said that we want to study how many patients recovered like recover without complication after using the Tamiflu. So the first outcome would be flu with complication. That's the positive, because we also all the time start with the positive, which is flu with complication. And the negative will be flu without complication or complication negative. That's also important, because when we read the question, it says 40 patients out of the 60 patients who received the Tamiflu recovered. That means the 40 goes in the patient on the cell of the patients without complication, which is cell B, not A. For a moment, someone might think that 40 patients should go in cell A. No, because usually the positive outcome goes first and the negative outcome goes second. So in this situation, it's kind of tricky, because outcome, we want to know how many patients recovered without complication. So here they said 40 patients recovered without complication. So they should go into the cell of the flu with complication negative, which is B. So that's why we put here the 40 in cell B. Right? And we know we have 60 patients. That means 60 minus 40, we have 20 patients has some complications after Tamiflu. Same thing with the placebo group. We know that we have 40. We will immediately put 40 in the cell of C plus D. But we have to be mindful when we fill in number 10, which is only 10 out of these 40 patients recovered. So that means the 10 should go into cell D, which is the flu without complication or with complication negative, right? So if we have 10 with complication negative, that means we will have 30 with complication. We get that 30 from 40 minus 10 equals 30. This part is very important. Even if you spend time in filling the 2 by 2 table correctly, that will save the day, because the remaining calculations depends on how you fill your 2 by 2 table. Now we move to the absolute risk reduction calculation. And we have here, as we said, the risk in the intervention group. We take this 2 by 2 table from our previous one, and we calculate the risk. As we said, the risk is you take cell E, which is the number of the patient who have flu with complication. We divide that by the total number of the patients in the Tamiflu group, which is 60. 20 divided by 60 equal 0.33 or 33%. The same way, we go ahead and calculate the risk in the control group by dividing C over C plus D, which is 30 over 40, and the result is 0.75, equivalent to 75%. So now we have the two risks. What we will do, we remember that the equation is subtraction of the two risks from each other. So 0.75 minus 0.33 equals 0.42. Or if we want to do that in percentages, it would be 75% minus 33% equals 42%. So what's the interpretation? What does that mean? That means the Tamiflu reduces the risk of the flu complications by 42% compared to the placebo. And that's the conclusion of this calculation, that if the patient takes Tamiflu, there is 42% risk reduction in the possibility of getting complications from the patients who take the placebo. This is an assumption in this scenario. It's not the actual reality in real life. It's a made-up example. It's not something that's true. It's not an accurate data. It's just for the purpose of this teaching video. It's just made-up example. It's not the actual numbers, right? We know that. Right, now let's move to the relative risk reduction, which is a very interesting measure. Why? I'll let you know why. So first, look at the name, relative risk reduction. We have the words relative, and I believe I mentioned that before. When we say relative, that means we are comparing two things together. Here, it happened to be risk. So we are comparing two risks by division. So by dividing one risk by the other risk. This is the first clue in the calculation of the relative risk reduction. So the definition of relative risk reduction is a proportion of risk reduction due to the intervention. And we have to mindfully look at the keywords here. We have proportion, and proportion means we're dividing two ratios by each other. And the second keyword highlighted here is the risk reduction. And we mentioned that risk reduction means we have to do some subtraction. We reduce something from something. So it might seem kind of complicated. We have to do proportion and we have to do reduction. And that's true, but we have a very simple way to do it. I'll explain. So if we want to translate that in mathematical equations, we will say the relative risk reduction equivalent to the incidence in the control group minus the incidence in the intervention group divided by the incidence in the control group. And let's take it one at a time. The incidence or the occurrence of the outcome in the control group is the placebo group risk, minus the incidence or the occurrence in the intervention group is the intervention group risk. So when we subtract them from each other, we will do the risk reduction part. And then the product of that, we will divide it by the incidence in the control group, and that will give us the proportion part. So usually, we will not do all of these calculations. There is a shorter equation I'll mention here, but I want to let you know the idea behind that shortcut equation. So the shortcut equation is relative risk reduction equals 1 minus the relative risk. Why is that? Because as you see here and follow my red arrow, if we divide the incidence in control group by the incidence in the control group, it's exactly the same thing. We divide two equal numbers, right? So when we divide them by each other, the product is 1, right? This is the 1 minus here the incidence in the intervention group divided by the incidence in the control group. That's actually the equation of relative risk, right? So instead of going through all of this equation, we can simply say that the relative risk reduction equals 1 minus the relative risk. And we know how to calculate the relative risk. This way, it's more easy and simple. So the relative risk equals A over A plus B divided by C over C plus D. We have the numbers here. So the relative risk equals 0.33 over 0.75, which is equals to 0.44, or if we want it in percentage, it's 44%. You can pause the video and do your own calculations to practice. But the idea is we calculate the relative risk first, put it aside, and then calculate the relative risk reduction by 1 minus whatever number we got. Here it happened in this situation, it's 1 minus 0.44, which is 0.56, or in other words, it's 56%. This is the relative risk reduction. So you can imagine here the importance of filling the 2 by 2 table correctly. It will make everything else easy and straightforward. Now, how can we interpret the relative risk reduction? For example, in this scenario, we have a relative risk reduction of 56%. The interpretation says that Tamiflu reduces the risk of flu complications by 52% in comparison to placebo. And someone might say, well, wasn't that the same way we interpreted the absolute risk reduction? Well, that's partially true. You know why? Because the importance of the absolute risk reduction and relative risk reduction is in the comparison of the two results together. So for clinical practice and for evidence-based decision making, we have to look into both the absolute risk reduction and the relative risk reduction to make our conclusion guided by the study that we already have done, right? So let me explain that further. So let's assume that we have other results other than the results that we just discussed. And if we have this 2 by 2 table, I know it's kind of tiny a little bit, but because I don't want to go in details into the numbers, I just want to show you how the difference between the absolute risk reduction and the relative risk reduction matters. So from this 2 by 2 table, if we calculate the relative risk, we will find that it's equal to 0.5 or 50%. I'll not repeat the equation of relative risk because I discussed that in a previous video, but it's basically the risk in the intervention group over the risk of the non-intervention group or control group. And by simple calculation, we'll find that it's 5% over 10%, and the result is 50%. And if we calculate absolute risk reduction here for this 2 by 2 table, we'll find out that the absolute risk reduction is 5%. And that's by subtracting the risk in the placebo group minus the risk in the intervention group, as we just discussed. For the relative risk reduction, it will be 1 minus 0.5, which is 0.5 or 50%. So you can do the math on your own, like you can pause the video and do the math, and you'll find these results. So the interpretation of the results means we only have 5% absolute risk reduction. And absolute means this is the actual absolute exact figure caused by the intervention that we are studying. assume this is a Tamiflu. So the Tamiflu absolute effect on the complications of flu or recovery from flu is just 5%, while the relative risk, the comparison between the impact of the intervention versus the impact of the placebo, that proportion is 50%. In other words, the intervention has a small impact when we just look into the impact specifically, separating it from any other factors. It's just 5%. This is the absolute risk reduction. 5% is not a big number. All right. In our example, on the other hand, that we discussed in the beginning of the video, we have these figures. Our relative risk reduction and absolute risk reduction are close to the 50%. So we have 42% for the absolute risk reduction and we have 56% for the relative risk reduction. That means this intervention has a very huge impact, even by itself. The absolute impact of this intervention is big, which is 42%. That's the only way that we can make our judgment regarding the significance of our intervention, by making this comparison between the two figures. So what would be the impact of this in our practice is what we will discuss in our next video, because we need absolute risk reduction to calculate something called the number need to treat. So if we want to apply this to the population, what is the number of the people that we need to treat with this medication to see impact in the whole population? We're talking here population-wise. So if we have a big absolute risk reduction, we will have a small number of number need to treat. I will not go into the details of the number need to treat in this video. I'll leave it for the next video, and I hope it is a good appetizer to stay tuned and stick around waiting for my next week presentation, in which we will discuss the number need to treat and number need to harm, and how all of these measures together direct the decision makers towards whether to implement this intervention in a bigger scope, like in population, or not. It doesn't worth it. So with that, I will conclude this presentation, and thank you so much.